Right, okay. Before starting, let me tell there is a little bit of network issue right here. So in between it may get stuck. So please cooperate. Huh? Yeah. Okay. So we had one portion remaining in circular motion, that is banking or angle of banking, that will finish. Okay. Professor,
Sir, your voice is very low, sir.
my voice is very low.
Yes, sir.
Okay, fine. So you are responding means you can hear me. No problem. Go ahead. Banking, okay, and angle of banking. So what happens, if you travel across the highways, or even if you're taking a bend on city roads, you will see that there is a difference in height between the inner periphery and outer periphery of the road, right? So that is designed for a purpose. What I'm telling is, suppose a road is bent like this. This is the inner periphery, and that is the outer periphery. So if we take these as the width of the road, this I'm taking as a D. What is D here? D is the width of the road, and between these inner and outer layer, if I can replicate it by a geometric diagram, it's like this. Okay, this is the angle theta, है ना? And this h is basically difference in height between inner periphery and outer periphery. Now this difference in height is designed for a purpose. For what exact reason it is being done? It is just done to negotiate the effect due to centripetal centripetal force. Because in the bending, had the road been flat, in corners, then cars would have been toppled easily. Okay, because there will be no force to negotiate the counterbalance of this centripetal force. The moment there is a height difference, then the centripetal force can be adjusted nice and smoothly by different components of weight, normal direction, as well as static friction. Correct. So I will do both the cases separately. First, I will take a general case. From there, I will discuss The cases like if the road is smooth, then what will happen? If the road is flat, then what will happen? And all these things. Okay. So we are taking a general diagram. The diagram that I'm taking, suppose we have bending like this. This is the angle theta, and a car is turning like this. So these are the two front wheels of the car, which are essentially connected by axle. Okay. The car is coming front way. Fine. No. So what are the forces acting on the car? So let me first identify them. First of all, in the downward direction, there is mg, correct? And in this direction, perpendicular to the road, normal action will act. So if this is theta, this angle is also theta, right? Horizontal direction towards the center, mv square by r. All right. And one another force acting, that is static friction. That is Fs. Fs is equal to mu s into n. Now, here is a very interesting point. See who is taking notes on behalf of Altaf. So, so now the thing I said here, this friction, it does not act along the road. Instead, it acts across the road. I will explain what is along the road and what is across the road. Check here. If I take a track, this is the track. The car is moving in this direction, V. Okay, na? Fine. This is the road. Okay. So this direction, this V direction is along the road. Okay. This is rear. This is along the road. Okay. And this direction, this is across the road. Okay, na? So here friction is acting in which direction? This is across the road. In this direction, friction is acting. Okay, na? I hope you are understanding. Right? So why I am taking the friction across the road? Because we are taking friction across the road, to be specifically saying static friction. We are taking static friction as Fs across the road because otherwise the car will swing sideways. Because if there is no friction to negotiate, the wheel will slip sideways. No, try to understand. The wheels will slip sideways. So if the wheels slip sideways, then the car will swing sideways. We do not want that scenario. So an ideal road allows the car to safely move without any considerable body roll, right? Yes, Pushkar?
सर वो इंक्लाइन पे बता रहे हो या टिल्टेड रोड है?
ये टिल्टेड रोड है ना, रोड ऐसे है,
अच्छा
रोड ऐसे है, ये है ना रोड।
हाँ
अभी समझ में आया?
समझ में आया सर। सर पिछला पेज भी दिखाओ सर।
वेट, हाँ प्रोफेसर।
से वो म्यूएस जो है वो ऊपर की तरफ क्यों नहीं लग रहा? क्योंकि उससे एमजी साइन थीटा को बैलेंस करना होगा ना।
नहीं नहीं नहीं, अभी मैं धीरे धीरे आ रहा हूँ वन बाय वन फैक्टर में। ये जो व्हील्स है वो व्हील का स्लिपिंग टेंडेंसी एज पर योर एक्सपेक्टेशन वो क्या है, मैं इस फ्रेम से दिख रहा हूँ ना, सो इफ आई एम वाचिंग फ्रॉम दिस रेफरेंस फ्रेम देन इसका व्हीलिंग टेंडेंसी जो है वो बाहर की तरफ रहेगा बिकॉज ऑफ द सेंट्रीफ्यूगल फोर्स। जब वो
ऐसे
बेंट कर
ओके सर, ओके सर।
जब तू बेंट कर रहा है तो कार के अंदर रहेगा ना, तो तेरे को किस तरफ फोर्स लगता है, अंदर की तरफ या बाहर की तरफ?
बाहर की तरफ।
बाहर की तरफ, तो इसलिए उसका स्लाइडिंग टेंडेंसी बाहर की तरफ है।
सर लेकिन उसमें एक mg sin थीटा कंपोनेंट भी तो होगा।
तो क्या फर्क पड़ता है?
सर उसे भी
मैं
तो
मैं इसको
बैलेंस
इस
करना
रेफरेंस
चाहिए
फ्रेम
वो।
से देख रहा हूँ, मैं अगर दूसरे रेफरेंस फ्रेम से देखूंगा तो उसको नेगोशिएट कर देगा वो। मैं आता हूँ उस बात पे।
ओके सर,
ओके,
थैंक यू सर।
या हार्दिक।
सर आज करंट नहीं है सर, इसलिए लेट ज्वाइन किया सर।
अच्छा,
फुल
कुछ
डे
नहीं
करंट
स्टार्ट
है।
हुआ, अभी चल रहा है, ये कहानी चल रहा
प्रीवियस
है,
पेज
देखो
सर।
दिखाता हूँ।
थैंक यू
दिनेश।
सर।
Sir, is the weight is of the wheels or the total car, sir?
टोटल कार, weight
Total
of the
car.
total
Okay,
car.
sir.
Okay, fine, right.
Okay, sir.
तो here this point you should remember carefully कि जो friction है, that friction is not acting along the road but it is acting across the road, ठीक है ना, थोड़ा careful लीजिएगा इसमें। Fine, so now let us see the components, okay ना, चलो 1 second please। So now when I am dividing the component, अब check कर लो, this will be theta, so this is n cos theta, this is n sin theta. Is it okay? Fine, no? All right. And this one is theta, so this is fs cos theta. This one is fs sin theta. Is that okay? Component division is fine for all of you. Have a quick check at the diagram, please. Take your rough copy and quickly draw the diagram once. Fine. Chalo. So let me redraw the diagram once again. Just the forces, nothing else I'm doing. I'm just doing about the forces. So if this is the system here, yes, Hardik, tell me.
सर वो प्रीवियस वाला पेज दिखा
दिखा
था
तो
सर,
रुक ना,
फर्स्ट
रुक
पेज।
ना।
ओके सर।
So this is mg and this one is mv square by r. In this direction you are having the normal reaction, so आपने इस एंगल को थीटा लिया, तो obviously here it will be theta, so this is n cos theta. In this direction you are getting this as n sin theta. All right, no? And along with this मैंने क्या बोला भाई, this is the direction in which static friction is acting along the road, तो ये fs हो गई आपका. So we have two components of fs, so then this will be theta, this will be fs sin theta, and this will be fs cos theta. I hope the diagram is clear to all of you. Now we want to write force equation, so writing force equation separately along x and y axis. So what is x and y axis here? Check out. This is x, this is y. So अब लिखो along x and y axis. Separately लिखेंगे. So first along x. So if I write equation along x, what I am supposed to write? N sin theta plus fs cos theta is supplying mv square by r. Correct? No? Fine. So now let us simplify it. N sin theta plus fs means mu s into n cos theta is equal to mv square by r. So if I take n common, we are getting sin theta plus mu s cos theta is equal to mv square by r. Let us call this equation number 1. Okay, no? Fine. Right. Along y, but there should not be any movement along y. वरना कार तो बम्प करते रहेगा फिर. So along y we can write n cos theta minus mg minus fs sin theta is equal to 0. So by taking this fs is mu s into n. So if I take n common, cos theta minus mu s sin theta is equal to mg. Okay, no? So let us call this as equation number 2. Okay, fine everyone. So those who have joined late, I'm just showing from the previous page. So take a snap. Yeah.
Thank you, sir.
So I hope up to this it is clear for everyone. Right? No? Fine. Okay. Right. Now, if I just do 1 by 2, you see n will be cancelled. So if I just do 1 divided by 2, what we are getting? See, sin theta plus mu cos theta by cos theta minus mu sin theta. Sin theta plus mu s cos theta divided by cos theta minus mu s sin theta is equal to will be cancelled, v square by rg. All right, correct. So from here we can write v is equal to root under of rg into sin theta plus mu s cos theta divided by cos theta minus mu s sin theta. Now this is the maximum velocity which can safely negotiate the banking. So I will write this is the maximum velocity which can safely negotiate the cornering. Okay, so you will tag this as this is the maximum velocity. Okay, is this fine for everyone? Right? Okay, those. Now let us have case studies. What are the case studies? The first case we are studying. So case 1. So case 1 we are studying if the road is frictionless. If the road is frictionless, this mu s is going to be 0. Okay, it's a very simple thing to imagine. So in that case, V max equal to, let us check how much you are getting. See, mu s equal to 0 means it is simply coming sine theta by cos theta. Okay, so the value will be root under of Rg tan theta. Even we will check, we will have a cross check. When we take the general case, whether we are exactly getting this value or not, that we will have a cross check. But from the previous equation, we are getting this value. Okay. Hi, yes, tell me.
सर आरजी एमजी लिया है क्या?
आरजी
आरजी एमजी को आरजी लिया है क्या?
नहीं, m तो कैंसिल हो गया ना. When you do it divided by 1 by 2, this m
हाँ
and
हाँ हाँ
cancel.
हाँ
R is the
बराबर
radius
सर.
of curvature of the road.
हाँ ठीक है
है ना.
थैंक यू
यस,
सर.
मैं लिख देता हूँ अगर कंफ्यूजन आया तो. So here I'm writing R is the radius of curvature of the road. Okay, is that fine? So R is the radius of curvature of the road. Chalo. So now let us study case 2. What is case 2? Case 2 is, Mama, good morning. Case 2 is, if the road is flat and rough. Now if the road is flat, flat means what, right? Flat means theta equal to 0 degree. Flat means theta is equal to 0 degree. So if you put 0, then sine 0 is coming to be 0. Only V term will serve. Then V is equal to, you are getting root under of mu s Rg. So this is the maximum velocity then. Correct? Understood everyone? Okay. Fine. So now let us see the general case. The general case in the sense कि when a cyclist, I will write like this, कि bending of a cyclist on a carved road. Now this one Puskar can understand better because he used to do all those wheelies, stoppy and all that thing. So suppose in one example, I'm taking this as a flat road. So whenever a cyclist is traveling on a flat road, I'm taking this as the wheel. Okay. Now, what are the forces acting on this? Sorry. What are the forces acting on it? One is the normal action, obviously. This is N in the downward direction. This is mg, right? And if it is standing on a flat road, then what will happen actually? Then the thing is that centripetal force will act in towards the bending. है ना? Correct only. But if the same cyclist on the same road is bending by some margin, like I'm taking this as the vertical axis. Okay, this is y axis. And now the wheels are like this. Like this. So in this case, what will happen? The normal action will be tilted. So this is normal action now, N, correct? I'm taking this angle is theta. All right. So here we can take the components. Fine. No? So if this is theta, this is going to be theta. So this is N sine theta, and this is going to be N cos theta. The other forces which are acting on the system, downward direction, vertically downward, this is mg, correct? And suppose this is F. So now you try to understand if I write the force equation. Now writing force equation, what will I write? I will write summation of Fy is equal to 0. From here I will write N cos theta is equal to mg. This is equation number 1. All right. Now along x, N sine theta is supplying the centripetal force, that is mv square by r. This is equation number 2. So if I simply do 2 divided by 1, aren't we getting tan theta is equal to v square by rg? So v value equal to how much you are getting? Root under rg tan theta. Correct, no? Let's check our previous result. Did we get root under rg tan theta? Check here. Right. So from the general discussion, we got root under rg tan theta, and from this particular representation, we are getting the same result, that is root under rg tan theta. So this is the maximum velocity with which a cyclist should take the corner or bend. Otherwise, what will happen? First aid will be required. Okay, professor. So next time you are riding a bike, I do not know whether you ride a bike or not. तेरे लिए तो स्कूटी ही सही रहेगा फिर. If you ride a bike, calculate your speed, bending. खड़ा हो जाना एकदम बीच सड़क में. ट्रैफिक भी रहा तो परवाह मत करना. फिजिक्स इंपॉर्टेंट है. बिल्कुल बीच सड़क में खड़ा होके पहले मेजर कर लेना सब चीज क्या है. लंबा सा फट्टा डाल के पुलिस वाला आके पीछे में 2-4 दिया तो भी फर्क नहीं पड़ता, मेजरिंग इंपॉर्टेंट है। उसको सीधा बता देना कि सर देखो अभी 2 साल बाद मेरा आईआईटी है, ये चीज आएगा आईआईटी में, तो पहले सारा चीज सीख के फिर अपना स्कूटी लेके पुलिस वाला जहाँ पे जाने के लिए बोले, बोला घर जाओ तो घर चले जाना, बोला थोड़ा थाने में आ जाओ खातिरदारी करेंगे तो उधर चले जाना। ठीक है ना प्रोफेसर, क्लियर? बिल्कुल। प्रोफेसर साहब एनी डाउट है अभी यहाँ पे कुछ?
नो सर।
क्लियर हो गया सब चीज?
यस सर।
अभी ठीक है, ओके। सो नाउ नेक्स्ट थिंग आई एम गोइंग टू डू कि presence of acceleration while bending. Okay, so basically we are doing all the basic stuff right now. I mean the theoretical part I am just covering. After that tomorrow and day after tomorrow we will discuss problems, we will consider all the cases. Okay, so today थोड़ा slow चलेंगे, slow. So suppose a body is taking a turn and it is saying that it has some acceleration. Acceleration in the sense what? It has some tangential acceleration, at. Now at is equal to what I write? R into alpha, where alpha is the angular acceleration. Alpha is angular acceleration, all right? So tangential force Ft will be equal to mass into tangential acceleration, that is equal to m into r alpha. Fine. This is Fn. Normal force कितना होगा भाई? mv square by r. Correct. So what is the net force acting on the body? Now net force acting on the body is equal to root under of f tangential square plus f normal square. So what is f tangential square, you tell me? M into r alpha whole square plus mv square by r whole square. All right. Okay. Now you try to understand one thing. For safely negotiating the bend, this must be managed by friction, क्योंकि आपका net force अभी इस तरफ आ जाएगा. This is the direction of net force. It must be managed by friction. Okay. So I will write what? I will now write for safely negotiating the bending or cornering, f net will be equal to small f. So I will write root under of, अरे ये क्या हो रहा है भाई, root under of m into r alpha square plus mv square by r whole square is equal to mu s into mg. Okay na? Now let me give you one warning here. Not necessary that everywhere we'll be using this situation. In general, at the easiest most possible scenario, we are doing this. Okay na? Yeah, Puska, tell me.
सर और एक बार बतला दो सर.
See, there are two forces which are mutually perpendicular to each other. So what is the net force? Net force is root under of f tangential square plus f normal square. So because of this force, the car will try to move sideways in the road. So if it doesn't have to move sideways in the road, it must be negotiated by friction.
ठीक है सर, थैंक यू.
Okay. Any doubt, please, with this one? Anyone? Anyone having any doubt? Feel free to ask. ओके, दिस इज ओके ना? फाइन। चलो अभी हम लोग प्रॉब्लम पे चलेंगे, ठीक है ना? विल वर्क आउट अ लिटिल बिट ऑफ सर्कुलर मोशन क्वेश्चंस। ओके फाइन, ठीक है, राइट। Anyone wants to take the screenshot? I will just keep them from the first page. You can take. Okay, come on, do it. 5 seconds for each page. Okay, done. All right, so let's proceed. Take time and solve it. There is no hurry. We are much ahead with the syllabus. Solve it, please. For your kind information, this block, it is in contact with the surface. Chalo, do it. हाँ भाई,
सर मल्टी करेक्ट है?
या मल्टी करेक्ट है। Yes, Bhanu. Bhanu, tell me. Can't hear you, Bhanu. Tell me once again. Professor.
Sir, option D.
Option D. Okay. Yogananda.
Sir, A and C.
Let us check. Dinesh.
Sir, option B and C, sir.
Pritam.
Option B and C, sir.
Okay. Yeah, Mr. Puskar Kale.
सर बी एंड सी सर।
B and C. Shankar.
B and C, sir.
Okay, Shankar. Chalo. So let us analyze. देखो, how to analyze this question. Sai. Okay, Sai. Very good. Excellent. Very good, Sai. So now here in this case, it is on flat road. So N1 is equal to mg. There is no problem. Here in this case, you see curvature is towards the downward direction. So this is the direction in which centripetal force will act. So downward force is mg, upward force is m2. So we'll write mg minus n2 is equal to mv square by r. So n2 will become mg minus mv square by r. In this case, just opposite of this thing, upward force is n3, downward force is mg, and curvature is in the upward direction. So centripetal force in the upward direction. So we'll write n3 minus mg is equal to mv square by r. So n3 is equal to mg plus mv square by r. No issue. So from the first two equation, we can clearly see that n1 is greater than n2. From the next two equation, we can clearly see n3 is greater than n2. It means n3 is greater than n1. So option A and C is the correct answer. Okay, fine. All right. Chalo, let us go for the next question. Now I request everyone, read the question, take some time. Do not give the answer in a hurry. Read the question very carefully, then only answer. Okay, na? Answer me. हाँ Chandra. Dinesh.
Sir, A, B, C.
चलो we'll check. Chandra.
Sir, in the previous question doubt, sir.
है?
Previous question doubt.
Previous question doubt हाँ? तो slow motion में चलता है क्या बे?
नहीं sir, internet connection.
बोल.
हाँ. ठीक है sir. In the N2 sir, mg why you took mg minus n2 here and n3 minus mg in the third case, sir? Can you tell?
Because you see the curvature of the road. When the road is carved upward, center of the curvature is here.
Sir.
So centripetal force will be towards the center of curvature. So now downward direction mg is acting, upward direction n2 is acting. So which force would be greater? Mg must be greater. So net force is mg minus n2. In the other case, it is carved downward, so center of curvature is upward. So here in this case, n3 must be mg so that the net force can be in the upward direction.
Okay, okay, sir.
Understood?
Yes, sir.
Chalo. So in this question, see, almost everybody is clear about B and C, but confusion is regarding A. So I will just clear A. What is A? See, A would have been clear if they only say car is more likely to slip at speeds higher than V. The problem is with lower. Yes, I. Okay, very good, beta. See, if the surface is smooth, then it's safe to drive at lower speeds. So when it is driving at the lower speed, there is nothing will happen, no. So slipping is only possible at higher speeds. Slipping is possible on higher speeds. So because of this presence, they have said higher than V or lower than V. That is why option A has gone wrong. So correct answer is B and C. हाँ बोल.
सर लोअर स्पीड पे कैसे मतलब ये होगा मतलब
बहुत सिंपल,
convenient?
बहुत इजी टू अंडरस्टैंड. सपोज तू कोई आईसी सरफेस पे वॉक कर रहा है, यू आर वॉकिंग ऑन द आईसी सरफेस, राइट?
हाँ सर.
तो तू क्या मतलब धीरे धीरे जाएगा तो गिर जाएगा. You can maintain better equilibrium when your speed is low ना.
सर वो फ्लैट का हुआ ना, टिल्टेड में तो अलग हो जाएगा ना. जब तुम स्लो चलोगे तो वो स्लिप कर जाएगा ना सर.
मतलब क्या है, नीचे की तरफ गिर जाएगा.
हाँ सर.
टॉपल कर जाएगा. तो कार का इंजन क्या है? कार का इंजन क्या साइकिल का इंजन है? Here we are considering that the car is being driven with constant speed. That means इंजन उसको constant power delivery कर रहा है. हाँ, अगर तू अब ये बोलेगा कि सर उसका इंजन का पावर इज नॉट सफिशिएंट एनफ टू पुल द कार, तो उस केस में तो गिर जाएगा ही वो. तो कोई भी केस में गिरेगा.
तो फिर हायर स्पीड्स पे सॉरी
लोअर स्पीड गिर सकता है ना. तो कभी भी गिर सकता है वो. हायर स्पीड हो, लोअर स्पीड हो, उसी एग्जैक्ट स्पीड हो, कहीं भी गिर जाएगा वो. द कार इंजन पावर इज नॉट सफिशिएंट एनफ टू पुल द कार एट कांस्टेंट स्पीड, किसी भी स्पीड में गिर जाएगा वो.
सर और car cannot remain in static equilibrium in curved section.
हाँ, it cannot remain in static equilibrium क्योंकि उसके पास बेंडिंग है ना. तो नेट फोर्स तो एक्ट हो रहा है ना भाई.
हाँ.
Net force is not zero. Net force is acting on the car. So if net force is not zero, how can it be in static equilibrium?
Okay sir, thank you.
है ना? Okay. चलो फिर. Okay. Bye bye. Bye everyone. Bye bye.
I live inside my own world of make-believe. Kids screaming in their cradles, profanities. I see the world through ice covered in ink and bleach. Cross out the ones who heard my cries and watched me weep. I love everything. Fire spreading all around my room. My world's so bright, it's hard to breathe, but that's alright. Hush. Tape my eyes open to force reality. Why can't you just let me eat my weight in glee? I live inside my own world of make-believe. Kids screaming in their cradles, profanities. Some days I feel skinnier than all the other days. Sometimes I can't tell if my body belongs to me. I love everything. fire spreading all around my room. My world's so bright, it's hard to breathe, but that's alright. Hush. Content, hold your breath and feel the tension. Devils hide behind redemption. Honesty is a one-way gate to hell. I wanna taste consumption. Breathe faster to waste oxygen. Hear the children sing aloud. It's music till the wick burns out. Be carefree lately, yeah. Just kicking up daisies. Got one too many quarters in my pockets. Count 'em like the 4-leaf clovers in my locket. Untied laces, yeah. Just tripping on daydreams. Got dirty little lullabies playing on repeat. Might as well just ride around the nursery and count sheep.